Hello to the Periodic Table Explained, Part 1. In this series, I will talk about the periodic table and explain every part of it in a simple way. This is Part 1, and today we are going to dive deep into elements, atoms, radioactivity, how the periodic table is constructed, and the basic element hydrogen. So, what are elements? And what are atoms? Elements are the basic building block of everything in the universe. From stars to humans to pizza, everything is consisted of elements. Now, imagine you have a block of iron. That is an element. But if you break that iron down, it will become an iron atom. That is an atom. So a lot of atoms become an element. And an atom consists of a proton, a neutron, and an electron. In the most simplest atom, hydrogen, there's only one proton and one electron. Now, a proton has a positive charge, while an electron has a negative charge. They always cancel out each other, and they don't produce any charge at all. And as you can see, there are shells in every atom, and the first shell could only hold 2 electrons, and the other shell could hold up to 8. What are compounds, molecules, and mixtures, and what is the difference? Now, as you can see here, are red things fused together. Those are oxygen, 2 oxygen, O2, that's what we breathe in. And if the red stuff is oxygen, then something 2 of something and 1 oxygen, that must be hydrogen, H2O, water. So if this is H, then this must be methane, and this is carbon dioxide. This is just a very basic equation where it has to be balanced. We'll talk about this in future parts of this series. Now we'll talk about allotropes. Allotropes are different versions of one element, such as carbon, where there's 4 allotropes: diamond, coal, graphene, and Buckminster fullerene. That's a mouthful to read. Now, as you can see, this Buckminster fullerene is shaped like a ball, and graphene is sheets of graphite. Diamond is just vertical lines connecting the graphite. And coal, well, it's a whole nother story. Isotopes. Isotopes are basically different versions of an element, but it's kind of in a different way. It's in the atom itself. As you can see, this is a protium, this is a deuterium, this is a tritium. They're all technically hydrogen. This is a basic hydrogen. This is hydrogen with 1 neutron. Remember, neutron just adds weight. It doesn't actually affect any charge or anything. And this is hydrogen with 2 neutrons. You probably never heard of deuterium or tritium because they're pretty rare and nobody uses them anyway. Radioactivity. We all associate radioactivity with bad things like breaking your body inside out, like those things. Radioactivity is just a name for breaking stuff. Let's say you have a neutron here, and you will hit a uranium nucleus. Now, a nucleus is the middle part of a neutron, and it breaks, it splits, and there's energy, and sends some more neutrons flying, and then sends more uranium breaking, and then etc. There's a chain reaction, and then it creates a lot of energy. This is called this is called radioactivity. And if one of some of these gets in your body, it breaks your stuff. This is 2 periodic table, this I'll talk about the structure. As you can see, the big 2 letters are the short name and then the long name, the number, and the mass. The mass is including the protons and the neutrons. We all associate electrons as no weight. We write them as 0 because they just have so little weight that they are basically no use. They take up no weight at all. Hydrogen is the basic and simplest element. It is the most abundant element in entire universe, consisting of only one proton and one electron. It is the lightest element, and because hydrogen shells aren't full, remember one shell can fit two electrons and it only has one, so it's considered very reactive. And if your shells aren't full, the element will try to get that electron back no matter what, unless it's like exploding and fusioning, and it'll do anything to get that electron into itself. Fact zone. The sun is hot. Fun fact, the sun is a big fusion factory that converts hydrogen into helium. So it's not a ball of fire. Fire needs oxygen. And yeah, as hydrogen is used up, helium becomes more abundant in the sun. And the sun becomes bigger and more red. This is when the sun becomes a red giant and is nearing death. Lighter than air. The air is mostly nitrogen and some oxygen, and the rest is mainly argon, which are elements 7, 8, and 18. That means only 6 elements are lighter than air, element 1 to 6. But only hydrogen and helium is gas. Lithium, beryllium, and carbon are all solid at Earth temperature. Wait, forget carbon. Forget carbon. Boron, on the other hand, just slightly lighter than nitrogen, is also never found natural on Earth. It's found in borax, but it's just a mixture. One more note. I was talking about mixtures and compounds, and there is one thing you have to remember. Mixtures are mixed in physically and could technically be separated again by physical or chemical reactions. On the other hand, mixtures that are chemically mixed are called compounds or molecules. They can't really be separated unless you use some really hard stuff to do it. So yeah, this is just about it for this part 1 series of the periodic table explained. Let me know what you want to know next. I'm thinking of doing the alkaline metals next, and this periodic table, you can look it up. It's really interesting, and this is it for part 1. See you next time, and I'll see you